So we were talking about this specific heat equation. And basically, let's bring that back to what we were talking about before. You use that equation when there's a change in temperature, and there's a change in temperature on these parts of your heating curve. So 1, 3, and 5 are the parts where you would use that heat equals mass times change in temperature times specific heat. And that's because change temperatures are changing, right? When things melt and when things boil, things are flat and there is no change in temperature. So in case you're forgetting that, here it is, right? When you heat something up and there's a change in temperature, it's one substance, it's one state of matter, and it becomes no change in temperature when it's melting, when it's changing states, or when it's boiling. So there's change in temperatures when it's one state. When it changes states, then there is no change in temperature. So if there is no change in temperature, how on earth are we supposed to take care of this? Well, that's why we have these things, the heat of fusion and the heat of vaporization. Now, we're only going to deal with water. So the heat of fusion will be 334 joules per gram, and the heat of vaporization will be 2260 joules per gram. But understand that if we use different substances like methanol or ethanol or gold or whatever, we would have different quantities, different numbers as those constants. So this is sort of like the specific heat, only when the temperature isn't changing, what you need to use from a reference table as something. So we're going to talk about that in the flat parts only. So when there's a change in temperature, 1, 3, and 5, you do not need delta H fusion or delta H vaporization. Specific heat is what you use for those parts. When things are changing states, so at level 2 and level 4, um, so here, right, when states are changing, then you need either delta fusion or delta vape. Now, thanks to e-cigarettes, everyone knows about vaporization, right? Everyone knows what delta H vape is. That's when something turns from a liquid to a gas. That's what vaping is. So anytime something turns from a liquid to a gas, in this case, we're going to use water, you multiply the grams of water by this constant 2260, and that's how much energy is released or is needed for water to go from liquid to gas. It's also the energy released when gas becomes liquid. That's why a steam burn hurts, because you're going backwards, and it puts 2260 joules per gram into your arm. Okay. Solid to liquid is fusion. Now, that one's a little harder to remember. You can remember it as being the thing that's not vape, okay? But anytime water is going from a solid to a liquid, so when you're melting water, you need to put in 334 joules per gram of water to melt it. If you're going the other way and you want to freeze water, then you have to pull that energy out. Okay. So it's either you're putting 334 in to turn ice into liquid water, or you're pulling 334 joules per gram out to turn liquid water back to ice. So the equations are much simpler. You're just going to take the mass and multiply it by the delta H fusion if it's melting or freezing, and delta H vaporization if it's boiling or condensing. And you're going to use these numbers because we're only going to deal with water. So here's an example. Well, actually, before we get into the example, this Antoine Lavoisier was the same guy who did the balancing reaction things. He was always chasing this thing that heat does not have mass, and everyone at his time believed heat had mass. So one of the things he was going to do to prove this, he made this very elaborate ice cage for a guinea pig. And the idea was that there'd be a supply of air because he wasn't cruel. And then he would put the guinea pig into this ice cage. It's not funny. And the warmth of the guinea pig would melt the ice. And then he could measure how much ice melted. And because of the heat of fusion of ice, he could then figure out how much heat was lost by the guinea pig. I assume before it died, but I don't know what when the experiment ended. Back in those days, they probably just waited for him to die. But then why give him air? I don't know. Anyway, um, that's just an aside. When we do it with humans, we're much more generous. We just put a water wrap around the human and we measure that way. But anyway, that's neither here nor there. Here are the kind of questions you would be asked. There's no change in temperature when something is freezing. We just talked about that, right? Those are the flat parts of the graph. So if I give you some amount of grams of water and it's freezing at 0 degrees, you need to use heat of fusion because freezing is a conversion from liquid down to solid, right? So that's fusion. And we're just going to plug this in. 334 joules per gram is the given for water. So that's for water. And we're not going to deviate from water in this class. And then you take the grams of water that were needed, 480, and notice your grams cancel and it gives you joules. So just like what did with the specific heat, where everything cancels to give us joules, right? Everything cancels here to give us joules. The same thing is going to happen here. We're going to cancel to get joules. All right, so that's when there's a liquid to solid. If there's a liquid to gas, and that's what sweat is supposed to work on this theory that a liquid becomes a gas on your body, and in the process, heat is released from your body into the atmosphere. So if you have 500 grams of sweat, and that sweat evaporates. So we're talking about the delta H vape, right? Talking about liquid becoming a gas on your body. Now that doesn't work in the South because it's so humid. The liquid has nowhere to go but on your body, and so you don't ever feel the benefits of sweating. But if you've ever been to Arizona or a dry place like that, when you get out of a pool, you will feel very cold because all that um, liquid evaporates off your body very quickly and you feel that heat leaving your body. So that's your delta H vape that's happening. But anyway, so if you actually were in a situation where sweat would leave your body and 500 grams of it left your body over some time, you would multiply that grams by the delta H vape, cancel your grams to get joules, and that means 1.13 million joules left your body as a matter of just sweating 50 grams. So that's how sweat is supposed to work at cooling your body. All right, so the point here is you always use at the flat parts either fusion or vaporization. Okay, and that these numbers will be set because we'll only be talking about water. We will not talk about other substances which would have different numbers. So anytime it's liquid to solid or solid to liquid, you're going to use that 334 joules per gram. And anytime it's liquid to gas or gas to liquid, you want to use that 2260 joules per gram.